So you all know what to do, right? I'm just making you practice doing it in-class assignments and so on to help you study before your final exam. You know your final exam's on the very last day, the very last afternoon?
Discrete math.
Yeah, well, discrete math, which would mean it's your last exam, right? There are no other exams after this. So just go back to what we talked about at the beginning. If you use this approach, basically you're asking to do the same thing here, it's easiest. Node 1 has 2 edge, node 2, 4, and so on. So by our definition, you can see that this is an Euler trail because exactly two nodes have odd number of edges. Even, these two are odd. So it's an Euler trail. So to make this into an Euler circuit, for example, we can add one edge here. So now they're all even. So we add 2 edges, then this becomes an Euler circuit. So in other words, if you add an edge here and here, that becomes an Euler circuit. So again, for most of you, it's better to list it, nodes, number of edges, and then answer the question. Or I forget to show, this also becomes 4. But still even. 1, 2, 3, 4. Okay, while this is true, it doesn't mean this is the fewest number. I added 2 edges here, and I make it an Euler circuit. But I can actually add 1 edge, and it still is Euler circuit. I can add a single edge. I can introduce multiple edge. For example, that is actually an Euler circuit. So in this example, I added 1, 4. So this is what I did here. So actually I added a single edge. No longer a simple graph, but it is an Euler circuit. It's not a simple graph because we have parallel edges. But if we say fewest number of edges adding, I can just add 1. Any questions? Is that clear? Do you understand? Are you listening? Have you finished? Anyone finished yet? Have you finished? Still thinking? Any questions? You look confused. So why? Why are you confused? About the question. You have to write this down in your paper. Have you done that? On the piece of paper that you have to answer this. You have to write this on your piece of paper. You done? If you need more paper, I have more paper. Anybody else need more paper? If you have more than one page, make sure you submit both pages, all of them. Have you finished yet? Come on. Not difficult. Especially after I show you this. Should be straightforward. Okay, when you're given a question like this, to be correct, he asks fewest number of edges possible to make the graph Eulerian. That means add 1 or 2 or whatever fewest number to make it either an Euler trail or Euler circuit. If you add 1, it becomes an Euler trail, then the answer is 1. If you need 2 to make an Euler circuit, but 1 for Euler trail, the answer is 1. Because fewest to make it Eulerian. Eulerian means either a trail or a circuit. Doesn't matter which one. So you can try to find out a solution for Eulerian trail, Eulerian circuit, how many edges for each of these, and then take the one that's the fewer one, fewest, and that's the fewest. That's the answer for this. Okay, just want to show you this from the textbook, what we talked about earlier. So remember I asked you the relationship between, or comparing between the sum of the degree for each node and the number of edges. So in any graph, this is actually another theorem. The sum of the degrees of the vertices is equal to twice the number of edges. That's what I told you. We counted 22, sum of degree of nodes, and we have 11 edges. So that's satisfied. We can actually express it in this form. Summing all the degrees of each node for all the nodes equals to 2 times the number of edges. M is the number of edges. So this is actually a theorem. We can prove that actually not difficult. This is sometimes called a handshaking theorem. It's not mentioned in this textbook, but sometimes you also hear the term handshaking. When you shake hand, it takes two people. Two people shake hands. So 2 nodes, each edge is the hand shaking. So it's also called a handshaking theorem because it takes 2 people. You can shake with yourself, I guess, but usually you shake with somebody else when you shake hand, right? So it's also called handshaking theorem. Okay, just want to show you this because we talk about this. So this is actually a theorem. It's not in your notes, but something that you should know. And sometimes we call that the handshaking theorem. Okay. All right, let's go on. So you're working on this. So there are other examples. So different versions of, but similar to what you have seen. So previously, C and D are both Eulerian circuits. So in this example, we removed some edges. So now these two are no longer Eulerian. So it's very similar to what you've seen before. In particular, these two are Eulerian. But if we remove this edge, this edge, this edge, this edge, this edge, for example, then this is actually non-Eulerian. And we do something similar here. So this is no longer symmetrical. Did you notice? Something's missing from the previous one. So the bottom line is these two graphs are non-Eulerian. So as an exercise, again, you can go through the same thing and add the fewest number. Now, so there's one thing to add an edge, right? So in other words, when you want to travel and you want to visit all the sites, but you want to do it a minimum time, but you want to use each street once. So, but to make it Eulerian means it's the most efficient way to walk. But sometimes you don't want to add an extra route. So in other words, I've been saying, add the fewest number of edges to make the possible graph Eulerian. I can also ask the same question and said, remove the fewest number of edges to make this Eulerian. So in other words, I find, okay, I want to be more efficient, but I want to visit all the sites, but I don't want to take extra time. But I want to visit, so maybe this site is not as interesting. I can remove this maybe, or whatever. So you want to remove an edge as well. It's also possible, right? Okay, so you don't have to do this in class. I'm just telling you, these are kind of problems may be posed to you. Not just adding, but removing. Okay, we're coming to an end because I'm going to pick select questions for you to work on. So now let's look at this, another practice question. So what if we ask a question this way? What is the fewest number of times you must lift your pencil to draw each of these following without retracing lines? So if you read the question carefully, that means we start, say, here. That's one. And then I lift it, and then I start another one. Lift it, another one. Lift it, another one. So that I did without retracing the lines. But I lift my fingers many times. Because I did a close walk here. Then I remove my finger. Then I did this walk, remove my finger, this walk, remove my finger, this walk, remove my finger, this walk, and so on. So, I mean, this is obviously not the fewest time. So if you can do it without lifting your finger, that means 0 times. That means if it's Eulerian, the answer would be 0 times. You have to lift your pencil. So this, for example, 1, 2, maybe 4. So now, think about this. Let's do the stick figure. So in class, I want you to work on this one. C, your stick figure. Answer this question for the stick figure. Add it to, you probably need more paper now. Add it to what you're writing now. So to do this, again, because this is not the representation you're used to. You're used to things like this, right? So you may want to label nodes and edges. So for example, the head is a loop. This is a node. And this is a loop that goes back to self. So label it as node and edges to help you solve this easy, systematic, step by step. Label these as nodes and edges, and then trying to solve it using what you have learned so far. Okay, so C, the stick figure. Let's have some fun. I want 2 groups of volunteers, one on each side, to work on C. Groups of 3. Form your own team, go up there, and see which team will solve it first. Any volunteers? No volunteers, and I will assign groups. Anybody want to volunteer? Form your own group. I have two sides of the board. Any volunteers? Okay, you need 3 people. Get 2 other people. 2 of your friends to come up. Okay, you have to find 1 more friend. 2 here. You have to pick someone else. 3. It has to be 3 people. Has to be 3 people. Okay. Ladies, you can pick your color. C, yes. Come on, guys. Which one? Let's go. You need 3.
อาจารย์เรียกอาจารย์เรียก
Do you have your own marker? Oh, from there. Okay, okay. That's true. Okay, good. You're doing C, okay? C.
only C
Only C.
แค่ทำได้ C
Only C.
เอาว่าดีมอสเอาเป็นสเต็ปเหรอ
So this is only visual. There's no reason, right? Why do you think that's the case? I know you got answers 3 right now. So the ladies, so far, 3. Can the guys find less than 3? Can you find less than 3? Lift 2 times, yeah. I mean 3 different times you draw, but lift your pencil twice. So they're all doing it visually right now. Nobody's doing it systematically. What is it?
Can I draw in the same line?
Can you go back?
Yeah. Can I go back?
Without retracing lines, no. You cannot go back. So each one has to be a trail. You cannot repeat the edge. Each one has to be a trail. So right now the ladies has 3. Can you do less than, 2 times lifting your hand? Can you do less than that? So it looks like you're stuck at 3. Is that right? Lifting your hand twice. You lift your pencil twice. Maybe the answer is correct. It is only, you have to lift it twice. You have to lift your hand twice, your pencil twice. So there are multiple solutions, but it looks like so far you found fewest number of times you must lift your pencil is 2. Anyone find anything less than 2? Okay, before you guys leave, can you write down, can you make them into, label the notes? Can you label the notes? Draw another figure somewhere, label the notes. Label the notes on your stick figure. The note. The vertices. Label them as A, B, C, D maybe. A, B, C, D, E, F, G. We use letters, alphabets to label the note. Can one of you label your notes? Write down the figure and label the notes. Right, label it like that. A, B, C. Label the notes. One of you do that, you have 3 of you. So how many notes we have? We have 9 notes. So how many edges for each note? Can you also summarize that? Write down the note, each note, how many edges, degree of each note. These are notes too. So with the information, note, and degree, can you make use of that to help you to answer this better? So looking at the notes, the number of degree of each note, obvious is non-Eulerian. So can you partition it into Eulerian subgraphs? That's basically what you're doing. I didn't say you can do it 2 times.
There is no 2 times, right, to finish.
Well, I want you to show, by looking at this, you partition it into Eulerian graphs. So you find subgraphs, subset of the graph, and you partition it so that they're separate. And you show each part is Eulerian. So we have a complete graph here. To answer this question, you break it into subgraphs. That's a partition, complete partition this. And then show each partition is Eulerian. If it's Eulerian, that means you can trace it without lifting your hand. Oh yeah, just count as 2.
It's just
I forgot.
2, right? This point, 2 or 3.
The loop has, I forgot to mention, for a loop, it's counted as 2 edges. Because it can go both either ways. A loop has 2 edges. So the degree is 2 for degree for that is 2. So this is not 4, this is 2 plus 1, this is 3.
Oh, yes, D.
Oh, this is, oh, which one's D? Oh, D's up there, okay, okay, yeah. So for example, this is odd and odd, right?
Yeah.
So this is an Eulerian trail. So this is fine. This is
Oh, yeah,
one.
yeah, yeah. I forgot. And then draw another graph.
Subgraph. Subgraph, yeah.
Am I right?
Mm-hmm.
Correct.
Yeah. So odd, odd,
Odd.
odd. So these are all Eulerian trails. So you can see the property here.
Yeah.
You add this, add this, add this, add them up, you'll get that, right? So you have to break that into subgraphs such that the fewest number possible. So So are you having fun? Fun watching your friends? Okay. Sorry?
The way to part of each graph and then multiply it, or to find the fewest way of the drawing this.
There's no one way to do it, actually. So basically, you have, I'm trying to explain to you, that you have complete graph here,
Yeah.
And then there are different ways you can break it into a subgraph. So how do you break this into subgraphs such that all the subgraphs are Eulerian? So this is basically a problem. And you wanted to minimize the number of subgraphs you have. So this is what we're leading to what's called a minimization problem. So we pose a problem, we define it this way, and then we will solve a minimization problem, which is not part of this course actually. But I'm just describing to you, you can do it this way, then you can pose the problem in a systematic way, then you can solve what we call minimization problem. Because basically, if you can put that in that form, then there are algorithms you can use to solve a minimization problem. Okay, I think that's all for now. Okay, thank you. Actually, before you leave, you can write your names on a piece of paper. 6 of you. You can write your names there. So I think they have spent some time trying to solve this, and you have fun looking at them and trying to do yourself. So the answer to this, actually, yes, is 2. You have to lift your hand twice. So that means there are 3 subgraphs. So one possibility is this one. One subgraph, second subgraph, and a third subgraph. So each of these subgraphs, as you can see here, is Eulerian. 2 odd edges, 2 odd edges, 2 odd edges. So this is fine. This is correct in the sense that we have Eulerian trail for these 3 subgraphs. But is it the fewest number? That doesn't answer that. So on this side, they're trying different things. I'm not sure what. They're trying to add lines to make it Eulerian, maybe. So, I mean, another question, obviously, is to say, can we add lines to this, make it more Eulerian? It's possible. It's a question to pose. So there are certain exercises. I would post these as, I guess, assignments. Maybe not all of these questions, but some of these questions. I will put it on the e-learning system, and you can work on it as an assignment. So the remaining time is a quiz. Quiz. We have a little bit of time left to do a quiz. You have paper in front of you. You have seen what people have done. Very simple quiz. Okay? If you have been following this, it will be very easy for you to do. C. Add the fewest number of edges possible to make each of this graph C Eulerian. If you need more paper, paper's here. Quiz, not assignment, quiz. That means don't talk to your friends. I need to get more paper, sorry. Okay, who needs more paper? Sorry? C. Only one question, C. You need to work on C. Three, 4, 5. I think that's enough. Yeah, you can write on the same piece of paper if there's enough room. You don't need new paper. But if you want, you can have a new paper. Sorry? Eulerian trail or Eulerian circuit, whatever. Fewest number to make it Eulerian. C. Okay? Remember, it's a quiz. Cannot talk to your friend. "15 minutes should be more than enough if you're paying attention in class. When you finish the quiz, you can leave. You can leave early if you want. Easy, right? Okay, thank you. You just guessing? I mean, if you go through this process, then it's obvious. If you just make the notes, count the edges, and then you can answer it very easily.
Oh, I thought it was 4. Okay.
But it could be 4. I'm not saying it's not 4. It's up to you if you want to go through it. All right. Okay, thank you. So next class is a little bit more theoretical. So you have to be prepared. Thank you. Oh, actually, can you submit everything, including the assignment, you should submit your earlier, the in-class work you did. Thank you. Thank you. Thank you. Thank you.
Wait, what's the lowest number you've done so far? Just curious.
It's 4. You're correct. I'm just saying.
No, I'm just curious because I'm just really thinking about it now. So.
Okay. Okay.